is the standard normal distribution. So first of all, the graph of the standard normal distribution look like bell-shaped. So if you have a normal distribution with center at 0 and standard deviation 1, that's called standard normal distribution. So we are going to use standard normal distribution here in this section. Okay, the graph of normal distribution can be approximated or can be plotted by using this function here as a function of x. If we try to plot that function, we're going to see this type of graph, which is bell-shaped symmetric graph. This is the normal distribution curve. This is called curve for the normal distribution. There is another type of distribution called a uniform distribution, where the area under the curve, area under the graph of continuous probability distribution is equal to 1, and there is a correspondence between area and probability. So if we plot the graph for the uniform distribution, the graph would be look like this, which is the rectangle. And for finding the area of the rectangle, we know area is height times width. So let's say this is height and this is width, this distance. So that's the uniform distribution. Okay, here's the one property of uniform distribution. The value of, as you can see here, the height is equal. The value of a continuous random variable has a uniform distribution if its values are equally spread. Okay. Density curve. The graph of any continuous probability distribution, whatever graph we're going to get, that's called density curve. And then area under the curve, density curve, is always equal to 1. Exactly. Under the curve is exactly 1. Because the area under the density curve is exactly 1, and we know that total probability is also 1. So there is a correspondence between the area under the curve. So for example, for the normal distribution, standard normal distribution, the area under the curve is 1. The area under the curve is 1. And we know total probability is also 1. So the area under the curve and then probability, we can find the correspondence between these two values. So here is the role of the standard normal distribution. If you have the standard normal distribution with the center 0 and then standard deviation 1, then area under the curve should be equal to 1. Okay, so now what happens is, for finding the area under the curve for certain g-square, for example, let's say the g-square is this g-square we're talking about, and we would like to find the area under the curve to the left of this g-square. In that case, we can use technology, or we can use table. Our book comes with the table, so either we can use table, but I prefer to use a StatCrunch, so I'm going to use a StatCrunch for finding the area. Sometimes they give you the area and you need to find the g-score. Sometimes they give you the g-score and you need to find the area. Okay, so there are other ways to find the area versus g-square, but we are going to use StatCrunch. But if you are using the table, then there are some information you have to be careful with, and that's what it's given here. I'm not going to worry about that. One thing you have to keep in mind, that you should understand the difference between the g-score and the area. G-score, what is g-score? G-score, if you look at the formula for the g-score, it's the how many times the value, the x, is far from how many standard deviation times. G-score is equal to times the standard deviation is equal to the difference between the value of x. X means the data value from the center. So how many standard deviation the data value is far from center, that measurement is the g-score. That's a different thing than area under the curve. Okay, so as I mentioned earlier, there are different ways to find the g-score versus area, or area versus g-score. We are going to use StatCrunch. Okay, so let's look at some of the problems, but before that, let's understand the meaning of this notation. This first one is the probability uh, such that the g-score is in between a to b, meaning we would like to find if the g-score is going from a to b, what is the probability of that. That can be found by finding the area under the curve from a to b. So that denotes the probability that g-score is between a and b. So this second notation is, probability such that the g-score is greater than some value a, and this is the probability such that g-score is some value less than a. Keep in mind, the probability can be calculated by finding the area. Okay, so if you know the g-score, you can find the area under the curve to the left or to the right of the g-score, and if you know the area, then you can find the g-score from that area. One more thing I would like to mention here, that's called critical value, and this is the notation for the critical value, g alpha. This denotes the area under the curve for the normal distribution such that this denotes the g-score. This notation denotes the g-score such that area under the curve, I'm talking about the standard normal distribution curve, to the right is equal to alpha. So the area under the curve to the right of this g-square is equal to alpha. That's called critical value. Okay, that's called critical value. So let's look at some examples from section 6.1. Before we start the problem, let's look at the question number 19 here. Which of the following is not a descriptor of a normal distribution of random variable? So the graph of the distribution is symmetric, that's right. The graph is centered around the mean, that's right. The graph is centered around 0. That's not part of the normal distribution. It's supposed to be part of a standard normal distribution. That's the difference. Okay. Which of the following groups of terms can be used interchangeably when working with the normal distribution? So when we work with the normal distribution, area, probability, and relative frequency, they have same meaning. Which of the following is not a requirement for density curve? Every point on the curve must have a vertical height that is 0 or greater. Yes. The total area under the curve must be 1. Yes. The graph is centered around 0. No. The curve cannot fall below the horizontal axis. So this is not true. Which of the following does not describe the standard normal distribution? The total area under the curve must be equal to 1. That's right. The graph is uniform. No. For the standard normal distribution, the graph is bell-shaped. Fill in the blank. Finding probability associated with distribution that are a standard normal distribution is equivalent to finding the area of the shaded region representing that probability. This is the most important summary for this section 6.1. If you understand this line, then that means you understand the section 6.1. Okay, the notation, this denotes the probability such that g-score is less than 1. The probability that g-score is less than 1 is less than, not 1, sorry, less than a. Okay, so these are some understanding questions. Now let's go to solve some problems from this section here. What requirements are necessary for normal distribution to be standard normal distribution? The center should be 0 and standard deviation should be 1. That's the requirement. Okay, let's look at, this is the normal distribution we have given such that the center is at 0 and standard deviation is 1. We would like to find out the area under the curve from g-score negative 0.98 to g-score 1.24. To solve this type of problem, we are using StatCrunch. So go to the StatCrunch, go to Stat Calculator, and then Normal Distribution Calculator. Keep in mind, this section is about the standard normal distribution such that the mean is 0 and the standard deviation is 1. So these are the default value. Now we would like to find the area under the curve between these two z-score. So use this between option and just replace this z-score by corresponding value, which is 0.98 to negative 0.98 to 1.24. So if you just fill out this value and hit compute, that's going to give you the area under the curve, which is 0.72896. So if you round it to the 4 decimal place, because after 4 decimal place there is a 6, so this becomes 10, and so that will 0.729 actually. 0.729. Okay, let's do another problem. Let's say this is the problem you want to find. Here we have given area under the curve to the right side of the z-score, and we would like to find the z-score. So by using the same calculator, but this time it's a standard calculator, remember the area is given here, so the mean is 0 and standard deviation is 1. It's already given. The area means the right side box here. You just replace that by 0.1292. And you also have to make sure that this sign, if it's right side, then it's supposed to be greater or equal. Look at here. You always find the same graph. If this is right side, it's supposed to be greater or equal. This is the z-score, such that area to the right side of that z-score is 0.1292. So if you round it to the 2 decimal place, that would be 1.13. 1.13. That's the answer. Okay, so let's look at next problem. Okay, this problem. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean 0 and a standard deviation of 1. That means we're talking about the standard normal distribution. Draw a graph and find the probability of bone density test score greater than 0.26. So greater means to the right side of 0.26. So this is the only curve you have where you have 0.26, and then the shaded region is greater than that 0.26. Now what is the probability? You go to the normal calculator here, choose the greater than, and then put area under the curve. We need to find the area. That means the probability means area. So put the value 0.26 here. Then it gives you the area to the right side, which is 0.3974. That's the area under the curve, 0.3974. Keep in mind, area under the curve of standard normal distribution is equivalent to the probability. So that's the answer. Okay. Okay, let's look at the next question here. Assume that a randomly selected subject is given a bone density test. Bone density test scores are normally distributed with the mean 0 and standard deviation of 1. That means it's a standard normal distribution. Draw a graph and find P13, the 13th percentile. This is the bone density score separating the bottom 13%. So from the top 87%. So to the left side of the curve, there is a 13% area. So this is the right option. Look at here. To the left side, so it's supposed to be to the left side of the center, and that is 13%. Now we know the area under the curve to the left side of this score is 0.13. We need to find the value. We just need to do the very same thing here. Use the normal distribution calculator here, and the area to the left side is 0.13. And if you hit compute, that will give you negative 1.12. Negative 1.13, because if you round it to the 2 decimal place, it's a 1.13.